All right, in this video I'm going to go over sections 10.3 to 10.5, which is all about hypothesis testing for a population proportion. So I'm going to do a few examples of 3 different types of tests. All of these come from the textbook. So in a survey of 1,000 women aged 22 to 35 who work full-time, suppose 540 indicated that they would be willing to give up some personal time in order to make more money. The sample is selected to be representative of women in the targeted age group. So the question is, do the sample data provide convincing evidence that a majority of women aged 22 to 35 who work full-time would be willing to give up some personal time for more money? So test the relevant hypothesis with alpha equals 0.01. So here, if you want to start, our target parameter is P, which is essentially the true proportion, right, of all women working full-time, age 22 to 35. I'll just write who would give up personal time in order to earn more money. Okay, so that's what we're actually looking for here. Or trying to make a claim about. So the first step is to construct the hypotheses. So we want to know, it's sometimes better to start with the alternative. So we're trying to answer the question, right? Is there convincing evidence that a majority of women, right? So that means, is there evidence to say that this proportion is bigger than a half, right? So once we set the alternative, we can go ahead with the null and say, let's assume that it is a half, and then we'll try to prove that, right, that it's bigger. Okay, so once we have our hypotheses, and just so you remember in the formulas to follow, right, this is what's going to be called P0. That's like our claim. So we find sample data. So our sample is from 1,000 women, and P hat would be 540 over 1,000, which is 0.54. Okay, so it's good that it's 0.54 because it fell on the correct side, right? That is a majority in this case. But that's just sample. That's just a sample, correct? So it could have landed anywhere. That's what we're kind of assuming, right? Because the sample was random. Is it significant that it did fall on this side? That's the question we're trying to answer. So here we can find the mean, which is always P0, which is 0.5, and the standard deviation of the sampling distribution. So that's the square root of P0 times 1 minus P0 over n. So this would be the square root of 0.5 times 0.5 all over 1,000. So put that in the calculator real quick. So we get the square root of 0.5 times 0.5 divided by 1,000. And that is 0.016. All right, so part 4. So this means I want to find the z statistic now. So that is you take your p hat, you subtract off the mean, and you divide by the standard deviation. So you take 0.54 minus 0.50, which is the mean, or just 0.5, divided by 0.016. And you get 2.5. So p hat fell 2.5 standard deviations to the right. So the p-value then would be the probability that z is greater than 2.50. And that we have to do look up in the table. So if I look up 2.50 and then subtract it from 1, I would get, so this is 0.9938, so that is 0.0062. So we can make a conclusion. 0.0062 is absolutely less than the alpha value, which is 0.01, so that means we can reject the null. All right, so we can say that there is convincing, right, evidence for the alternative, which means that there is convincing evidence that a majority, right, of women aged 22 to 35 would give up personal time. Okay, So that is just me translating, right, what the alternative is in terms of the proportion. So let's do another example. So say a representative survey of 983 likely voters in the United States included 440 who indicated that they think that women should not be required to register for the military draft. So at a 0.05 significance level, determine if there is convincing evidence that less than half of likely voters in the United States think that women should not be required to register for the draft. So in this case, P is the true right proportion of U.S. voters who think women should not have to register, right, for the draft. So this is very similar to the previous example. So if we're trying to find, in this case, if it's less than half, that actually tells us what the proportion is. So I'm trying to look for, right, is this true proportion less than half? So I'll set the bar at 0.5, right, and I'll test to see if it's less. So this, again, is what I'm calling P0. Okay, so step 2 then is to go out and find the sample. Well, we have 983 voters, and so P hat would be 440 over 983, which, put that in your calculator and we get 0.45. So in our sample, we actually got 45%, correct? But is that significant, right? Is that significantly below 0.5 to actually conclude that there's a minority of people who feel this way? So part 3 says, okay, find the mean. Well, that's always just B0. And sigma is the square root of 0.5 times 0.5 over the sample size, which is 983. So put that in the calculator, and we get 0.5 times 0.5 divided by 983, which is 0.016 again. All right, so step 4, so the z statistic. So that is, you take p hat, which is 0.45, minus 0.5 over 0.016. So get negative 3.13. So 0.45 is 3 standard deviations below 0.5. That's pretty significant, but let's put it to bed with the p-value. So here the p-value would be the probability that z is less than 0.313. Looking 0.313 up in the table, we get negative 3.13. We get 0.0009. That's a pretty small p-value. So our conclusion is, well, first I compare 0.0009 to 0.05. That's clearly less than, so we can reject the null. Therefore, there is convincing evidence that a minority, i.e. less than half, of U.S. voters feel that women should not have to register. So most people do think for the draft. Okay, most people do think that they should have to register by this evidence. All right, so that's a left-hand sided hypothesis test. Now, both of these examples had P being claimed to be 0.5. That's not always how it's going to be, right? I can claim P to be anything. It turned out that this is what it is. So let's try another example, and unfortunately, P turns out to be 0.5 here again. So let's look at this example. So in a recent survey in a journal, 229 women surveyed who said that they would like to choose the sex of a future child. And the journal states that there was no greater demand for boys or girls. So they said there really is no preference. However, the journal article then states that of 229 women surveyed, who wanted to select the baby's sex, 89 wanted a boy and 140 wanted a girl. So does this provide evidence against the statement of no preference? So basically, was the journal okay in saying that, oh, there is no greater demand for either boy or girl? So first off, I'm gonna just pick one of the two things. So let P be right, the proportion of women who choose to have a boy. So here I have to pick P to be something. I'm going to choose the success to be they chose a boy. So if that's how I'm going to lay things out, right, then what's my null and alternative hypothesis? Well, if the journal is stating there was no greater demand for boys or girls, they're saying that essentially, real quick, that P, this proportion, is 0.5. Right, so this is what the journal is saying, correct? No preference. So this is the journal's claim. Okay, so we're going to say the alternative then is that it's simply just not equal to 0.5, right? We're going to claim, well, the alternative is going to be that there is a preference for boy or girls. Okay, so it doesn't matter which one, I'm just saying, right, it's definitely not 0.5, that's the alternative. So here I'll just say there is a preference. Okay, so let's continue. So this will be a double-sided test. So then we do the sample, right? So the sample was n equals 229 women. So P hat in this case, I'm going to choose only the boys. So that'll be 89 over 229. And I get 0.39. Okay, so mu sub P hat, that's 0.5. And sigma P hat, it's the square root of 0.5. And again, the null hypothesis has been 0.5 every time. It doesn't always have to be that way. So here I have 0.5 times 0.5 divided by 2, square rooted 0.033. Okay, so next is the z statistic. Let's see how far away this thing is from the mean. So z would be 0.39 minus 0.5 all over 0.033. I get negative 3.33. So then the p-value is, here's where it's different, sorry. So since it is a two-sided test, I have to do 2 times the probability that z is less than negative 3.33. So this is what I would have, this value right here is what I would have calculated, right? This is what we would have calculated if it was a left-sided test. So because it's double-sided, I still calculate that value, but I have to multiply it by 2. Because it just so happens that the boys landed on the left-hand side of my null hypothesis, right? It could have been equally probable that the girls were less popular in a sense, right? So I have to take that into account when I'm doing a two-sided test. So here, looking that value up on the table, negative 3.33, that is 0.0004. So 2 times that would be 0.0008. So that's still a pretty small p-value. So our conclusion would be, right, 0.0008 is definitely less than the smallest alpha value that we've considered, which is 0.01. So we can still reject the null. Thus, the data suggest, right, there is a preference. Right, the journal should not have made this claim. The journal should not have said there is no preference, right? Because the data definitely suggests that, right, the null hypothesis is rejected. So the claim of no preference is rejected. All right, so the journal was wrong.